Okay, ladies and gentlemen, we move now into chapter 4, which is on indices, and we did some work on indices in sequences and series when we had to do some calculations, didn't we, using the binomial expansion, and we needed to. What I'm thinking of is when we had such things as this, and we needed to expand out. The first thing we needed to do was rewrite this as x squared plus x to the minus 1 to the 7, and then we needed to look at the expansion in such a way as so if in order to look at this we pulled out this power of a power thing, and so we've done a little bit, all that sort of stuff. We've done a little bit of index work. Now I would have liked to have done indices, this section on exponents, exponentials and logs. I would have liked to have done this before the sequences and series. However, that's not the way the course is laid out for us. So we're going to go back and have a really good look at indices again now. Make sure our manipulations and our index laws are in place, and we're comfortable with those. And then we're going to move it forward and discover some new functions, that being the exponential function and the logarithmic function. So it's about a 3-week topic. But we're going to start out with some the index laws, and the index laws as laid out to us. There's some basics. If you've got if you're multiplying and you've got the same base, so x to the power of something times x to the power of something else, then what we can do is we can add those powers together, can't we? And if we've got division, we've got division and it's the same base. Remember, I keep saying same base, but that's so important. If that's x and y, then all bets are off. We can't go using this. Oh, okay, that was not so clever. See if I can bring all that back. Yep, there we go. And this equals x to the m minus n. Does it not? So I'm racing through these because I know you know this stuff. And we did this one, the power of a power rule, where those powers get multiplied together. What else do we need? Anything to the power of 0 is equal to 1. We've seen that before. And then we get into the fractional powers. So x to the power of 1/2. Hopefully you remember that that's equal to x, square root of x, and x to the power of 1/3 is equal to the cube root of x. This sort of stuff. So it's going to be really important for us to be good at converting between fractional powers and then these radical expressions. Radical expressions meaning square root, cube root, fourth root. They're called radical expressions. All right, but more generally here, x to the power of 1 over n will equal the nth root here of x. But even more generally, I suppose, x to the power, because we don't always have a 1 over n, we have sometimes a power here, a value here other than 1. So that's still the nth root of x, but now x is raised to the power of m in there. Good. Now, right, we've come across these negative powers. We know that they become fractions so that we can work them backwards and forwards, like I just went through with the binomial expansion. Negative powers work like so. So if we're going to generalize here, x to the minus n will equal 1 over x to the positive n. And then I suppose if it's a x to the minus n, then that's a over x to the power of positive n. Okay, so all that stuff, that's, I think, the collection of index laws that you need. So then it's just a whole bunch of practice. Might just do a couple of examples, look at a few equations as well using index laws. So I'll just pop a couple of examples up and I'll pause the screen. Okay, let's look at a bunch of examples now using our index laws. And what I'd encourage you to do here is, rather than just sit there passively and watch, is to get actively involved in this activity and do the questions. Do the questions yourself. So you can see 6 on the screen now. Maybe pause the video, write these down. I don't care, just on a scrap piece of paper or preferably in your workbook. But write them down, have a go at them, then press play, even in double speed, and whip through my solutions now. It'll happen really fast. But that's active participation in these YouTubes will advance your learning, I think, in a much richer way than just sitting passively, maybe dropping off to sleep as you go through this, and then maybe not picking up so much. So get involved, pause now, and have a go at these 6. Okay, now hopefully you've had a go at these. Looking right through at each example in turn, what I've got here is a bracket expression 2xy squared all cubed. So what I've got to make sure I do is I've got to cube the 2 as well as the x as well as the y squared. So the 2 got cubed to 8, x got cubed to x cubed, and the y squared gets cubed to y 6, multiplying our 2 by 3. Really important to pick up every element of that term. Now over here to 2, 36 to the half, well, that's equal to the square root of 36, is it not? Which is just equal to 6. And in question 3, 1/27th to the 4/3. And we could do this a number of ways, but what I'm thinking is 1/27th is 1 over 3 cubed. Maybe you did this another way, to the 4/3. And 1 over 3 cubed is 3 to the minus 3, and that's to the 4/3. And I know that now I multiply these powers together to get 3 times minus 12/3, which is minus 4, and that is 1 over 3 to the power of 4, which is 1 over 81. 3 or 4 steps there to get through to the end, but you could have done that a different way. You could have cube root 1 over, because this 3 here means cube root that. Take the cube root of that. Now the cube root of 1 over 27 is 1/3. You might have noticed that. Then raise 1/3 to the power of 4 to get 1 over 81. That would have been okay as well. Do 4, 5, and 6 now. 6 to the minus 2 I know is 1 over 6 to the power of positive 2, so 1 over 36. Over here to question 5, I know that in this example, 3/4 to the power of minus 2, well that's 1 over 3/4 to the power of positive 2, and that's equal to 3/4 to the power of positive 2 is 1 over 9 over 16, and that's equal to 16 over 9. In question 6, d to the power of 0, I know anything to the 0 is 1, but there's 5 times d to the power of 0, so that is 5, which would be different from if I put a little 6.5 question in here, 5d bracketed to the 0, then because the whole thing is to the 0, then that is just 1. Okay, you haven't done 7, 8, 9 yet possibly, or 10, 11, so pause again and then come back and check solutions. Okay, in now at question 7, 6x to the minus 3 divided by... Alright, now with this division, always good to divide your numbers first, so 6 divided by 2 is 3. Now, oh hang on a sec, before I do that, just had a better idea, I'm going to get rid of this bracket first. Always a good idea to get rid of brackets first. 6x to the minus 3 divided by, then let's 2 cube that, and let's cube my x squared. Now I've got 6x to the minus 3 divided by 8x to the... I'm going to put this into a fraction because I think it'll be easier to simplify then. Okay, my 6 and 8 are going to come down to, what, 3 and 4. Now I always remove my smaller power completely and I subtract it from the larger power. Now in this case, subtracting minus 3 ups that by 3 to 9. So my result, if I tidy this up, is 3 just on top over 4x to the power of 9. Again, possibly different ways of looking at that, but that's the way I chose to do it. And when you're doing this cancelling out, just always remember, if it's x to the 4 over x to the 6, then you remove the smaller power and subtract it from the larger. Here, removing the smaller power was minus 3. Subtracting minus 3 from 6 adds 3 to 6, gives me the 9. And therefore, 3 over 4x to the power of 9. Now question 8 here, the cube root of 27a to the power of 6. We've got a cube root, all this, we think of it as 27a to the 6 to the power of a third, if you like. And then 27 to the power of a third, well that's a cube root of 27, which is 3. Then a6 to the power of a third, multiply your 6 by your third, So you get a squared for question 8. Now question 9, to the power of minus 1/2. We might be smart here to go, righto, how about we flip these around? So 16w to the 4 over 9v squared. So I've got the reciprocal of that, but now to the positive 1/2. Because if you think, this would have been, we take that to positive 1/2 and we turn this into a 1 over, which is the reciprocal, looking at the reciprocal of that fraction. So these two statements are equal. Now it's, I think, easier to do. With fractions, when you raise to a power, you can deal with each of the numerator and denominator separately. So 16 to the 1/2, 4. W4 to the 1/2, w squared. 9 to the 1/2, 3. So that's the square root of 9. V squared to the 1/2 is just v. So 4w squared over 3v. Just generally, if you've got a over b to the power of m, then that's a to the m over b to the m. You can always take the brackets out, just take your numerator to that power and take your denominator to that power and deal with them separately. That's all we've done here. We've taken the numerator to that power, 4w squared, taken the denominator to that power, 3v, kept it as a fraction. Okay, I've got questions 10, 11, 12 to finish off. Now, in question 10, look, I'm solving equations now. I've got the same base here, so therefore I can equate my indices. So x minus 1 is equal to 5x. I can equate them because my bases are the same. So I get here 4x is equal to minus 1, and therefore x is equal to minus 1/4. Just check the technique there, same base, equate your indices. Now in 11, I've got 3 to the 3x plus 1, and I'm going to make 81 have a base of 3. I just know it's 3 to the power of 4. Now I've got the same base, I can equate my indices. 3x plus 1 is equal to 4, and therefore 3x is equal to 3, and therefore x is equal to 1. Now over here, I can't write 24 in a base of 3. But what I can do is I can get rid of the 3 by dividing by it. So now I've got x to the minus 3/5 equals 8. Now, what can I do here? I've got, I know that if I raise this side of my equation to the power of minus 5/3, minus 3/5 times minus 5/3 is equal to 1. So I know I'll get just x to the power of 1 on my left-hand side. And that's no problem with doing that. What I've done is I've raised the left-hand side to the power of minus 5/3. I'll do the same to the right-hand side. I'll raise that to the power of minus 5/3. So what I get here is x is equal to, I'm going to write 8 as 2 cubed, and to the power of minus 5/3, just so it's an easier calculation for me. 3 times minus 5/3 is minus 15/3 or minus 5. So x is equal to 2 to the minus 5, or 1 over 2 to the positive 5, which is 1 over 32. Lots happening with that one. Lots of fun to be had. Look at that. That was an important move there, wasn't it? Really important move where I multiplied by the reciprocal in order to get 1. So what I did was I raised the power of the left-hand side to the reciprocal of the power that I already had for x, so that my powers were dissolved and I just got x to the power of 1. Do the same to the other side and then work my indices magic in order to get my solution out. Remember, these questions are all non-calculator, so don't reach for those machines yet, please. Right, we can do now exercise 4A through to 4E, and I'll get you some work requirements for those. I'll see you soon.